guys, this is going to be the last video in our discussion of ionic compounds. Today we are going to talk about exceptions to the rule. So we're going to name ionic compounds that have transition metals. We're going to name ionic compounds that have something called polyatomic ions. So the exceptions to the rule. Here's our periodic table. Up until this point, we have talked just about main group elements. So we've talked about group 1 and 2. We jumped across and we talked about groups 3 through 8. Those are our main group elements. They are very predictable. They follow the rules. Now what we want to talk about today are our transition metals. So these guys in this middle section, and you will very quickly see they don't follow the rules. They can have different types of charges. So they can have +2 or +3. They can have a +1 or a +3. And there really is no rhyme or reason to predicting this. So when we write ionic formulas or when we write names of ionic compounds that include transition metals, we have to have an extra step here, an extra piece that helps us to understand. So here again is just a list of some transition metals, and what you see here is the different charges. The big take home on here is going to be how we write these names. So the older way to name them was to put the OUS or the IC on the end. But I think those are very, very confusing, and I'm so thankful that we've updated to this new system of using Roman numerals. So when we are talking about the charges for transition metals, we're going to use Roman numerals to tell the viewer what the charge is. So for example, here, if I'm talking about this iron with a +2 charge, I would use the Roman numeral 2 to tell the viewer, hey, by the way, talking about the one with a +2 charge. If I want to talk about the iron with a +3 charge, I use the Roman numeral 3, again saying, hey, by the way, this iron has a +3 charge. So here's how we name our compounds. This blue box and this green box should look identical to the last video that you watched. So the blue box is just the name of the metal. We simply write that down. We don't change it. The green box is the base name of the nonmetal plus IDE. So that doesn't change. Oxide, chloride, fluoride, etc. The only new piece we have here is this middle yellow box, and it's just telling us that the charge of that metal will be the Roman numeral in parentheses. So we're going to walk through this example together. So here I have 2 compounds of copper chloride. Both of these compounds exist. Both of them are perfectly acceptable compounds, but they're going to have slightly different names. So let's work through these 2 examples and look at how we would use this Roman numeral to differentiate between these 2. Oops. All right. So let's do this first one. When the formula is written like this, I can go ahead and assume that that's electrically neutral. So I assume that whoever wrote that down wrote it as an electrically neutral compound. So looking at this compound, I have to determine, well, what is the charge on that copper? So copper can vary. It's a transition metal. It can go from +1 or +2. Chlorine, on the other hand, is one of our main group elements. It's always going to have the same charge. So if I look at an ion of chlorine, what is the charge going to be on an ion of chlorine? It's always going to be a -1. So I've got one chlorine and it's attached to one copper. So what must the charge on that atom of copper be if this is electrically neutral? It's going to be a +1. Okay. So one copper has a +1 charge. One chlorine has a -1 charge, electrically neutral. So how would I write the name of this compound? I would write the name of the metal. So I would write copper. I would write the base name of the nonmetal plus IDE, so chloride. And because copper is a transition metal, I have to tell the viewer what the charge is. So in parentheses, I'm going to say, hey, by the way, this is a +1 charge. The way that we would read this is copper 1 chloride. Okay. So let's do this other one over here. So again, copper and chlorine, perfectly acceptable formula. This formula is also electrically neutral. So again, chlorine is going to have a -1 charge. But what do we notice about this formula? Yeah, it's got 2 chlorines. So what is the total negative charge that chlorine brings to the table? Well, if each atom brings a -1 and there's 2 atoms, the total charge that chlorine brings to the table is a -2 charge. So what must this one atom of copper be if it is to balance out that -2 charge? That one atom of copper has to have a +2 charge. +2 from copper, -2 from chlorine. That would be electrically neutral. So again, how would I write the name of this? I'm going to write the name of the metal, so copper. I'm going to write the base name of the nonmetal, plus IDE, chloride. And now I have to tell the viewer what the charge is on that copper. So I would put a Roman numeral 2 in parentheses. So the way we would read this is copper 2 chloride. So big take home here is transition metals can have more than one charge, and we have to tell the viewer what the charge is by putting it in Roman numerals. The other exception to the rule is something called polyatomic ions. So up until now, we've looked at single atoms coming together, a magnesium and a chlorine, a calcium and a fluorine, a copper and a chlorine. Polyatomic ions are a little bit different. Polyatomic ions are a package of atoms that carry a charge. So if I look here at carbonate, for example, the package of atoms is CO3. This is carbonate. And this package of atoms carries with it a -2 charge. So that negatively charged package can come together and form a bond with one of our positively charged metals. So that's what a polyatomic ion is. I have posted in helpful handouts a list of polyatomic ions. I would have that list with you as you're working through some practice problems. I would have that list with you as you are working through homework and quizzes and exams as well. It's something that will be very handy to have right next to you. So let's look at how we write names and write formulas with these polyatomic ions. So let's say we want to make a compound between magnesium and nitrate. So magnesium is one of our main group elements. It's in column 2A. It's going to give away 2 electrons, so it's got a positive 2 charge. Nitrate is right here on our chart. Nitrate, the package is NO3, and that package carries with it a -1. To write the chemical formula for this particular ion, we're going to use the same thought process that we used before. So we're going to flippity-flop the charges. So this 1 is going to be the subscript on magnesium. This 2 is going to be the subscript on nitrate. The way that we do that is we would write magnesium, Mg. We would put our polyatomic ion in a package. So I put parentheses around it to identify that as a package of atoms. And then that subscript 2 is going to go on the outside. So what that is saying is I need 2 packages of nitrate for every 1 atom of magnesium. You cannot change the subscript on the inside of this package. If I were to change this subscript right here to a 2, that would no longer be nitrate. That would instead be nitrite. So these subscripts that you see on the polyatomic ions are off limits. You may not change them. You can only put a subscript on the outside of the package or the outside of the parentheses. To name this, it's actually very, very easy to name. There is nothing that has to change. To name this, we are simply going to write the name of the metal. So magnesium. And this is why it's helpful to have this list of polyatomic ions next to you. When you recognize a polyatomic ion, you simply write the name of it. So I see NO3, that's nitrate. I just write nitrate. So the name of this molecule is magnesium nitrate. That wraps up our discussion for ionic compounds. You need to pause here and go practice. You've got your formulas and equations lab, which will be a great practice opportunity for you. You can Google ionic naming, ionic formulas, and there'll be more practice worksheets with answer keys that you have time to do. I'm going to try to get some helpful handouts posted to Blackboard with the answer key as well, so you have more opportunity to practice. But the only way to get good at ionic compounds and ionic naming is to practice them. So happy practicing!